Hello and welcome to all students. This is FY BCom semester second class Mathematical and Statistical Techniques second. In the previous lecture we discussed about the annuity. Now in this lecture we state the general formula for the amount in an ordinary annuity, and it is given like this. Let R denote size of payment, or we call it is installment. Size of payment, or we call it is installment. Now suppose R percentage means it is a rate of interest per annum. Rate of interest per annum. Annual rate of interest. And suppose N denote the duration of annuity in the year. So it is duration of annuity. And it is in year. Okay, so let us write the first formula for annual payments. For annual payments, or installment, the total amount A is equal to R inside the bracket 1 plus R divided by 100 raised to the power n minus 1 and whole divided by R divided by 100. Okay, so note that the actual capital invested is generally is so we note here that the actual capital invested gradually n is equal to gradually it is equal to nr. Okay, so write the second formula. So second formula for half yearly payments or half yearly installment. For half yearly installment, the formula for amount A is equal to R inside the bracket 1 plus R divided by 2 inside the bracket 100 whole raised to the power 2n minus 1 and whole divided by R upon 2 times 100. So we observe these two formulas for annual payment. See the term in the denominator here and the power, and see the term in denominator here and here, and look at the power, so you will observe the difference. And here we note that the actual capital invested gradually is equal to R into 2n. Now let us write third formula for quarterly payment or quarterly installment. For quarterly payment or installment. A is equal to R inside the bracket 1 plus R divided by 4 times 100 minus 1, 4 times 100 whole bracket raised to the power 4n minus 1 and whole divided by R upon 4 times 100. So we observe all these formulas, and here we write the note that the actual capital invested gradually is equal to rupees r into 4n. For monthly installment, so let us write the formula for monthly installment. Fourth formula is for monthly installment. For monthly installment, so total amount A is equal to R inside the bracket 1 plus R divided by 12 into 100 and whole bracket raised to the power 12 and minus 1 whole divided by R into R divided by 1200 bracket complete. So these are the formulas to get the amount after maturity amount for the annual payment, for the half yearly payment, quarterly payment and monthly payment. Okay, one need not take special efforts to by heart each of the above formulae. All these formulae are derived on the following basis. For half yearly installments, a year is divided into two halves or two half year. Therefore, number 2 is placed appropriately in the concerned formula, whereas for quarterly installment a year is divided into 4 quarters. Therefore the number 4 is to be placed appropriately in the above formula. Similarly, for monthly basis, the number 12 is to be placed in the formula. In fact, all the above formulae can be written in compact form as follows. So all these above formulae we can write in compact form like this. So we write here the compact form. The compact form of all the above formulae is A is equal to R inside the bracket 1 plus R divided by K times 100 whole bracket raised to the power Kn minus 1 and whole divided by R upon K times 100 and bracket complete, where A is the annuity in maturity or amount in maturity, R is periodic payment, small r is periodic payment, the small r is rate of interest per annum and denote the duration of annuity in years, and K denote the respective K represents the period when the payments are to be made. Hence, when the period of annuity is yearly, half yearly, quarterly, monthly. In case of yearly, the value of K is 1. In case of half yearly, the value of k is 2, and in case of quarterly, the value of k is 4, and in case of monthly, the value of k must be equal to 12. Must be equal to 12. Sinking funds. Now let us go to the next article of this unit, and that our name of article is sinking funds. Sinking funds. So first of all, we see what is meant by the sinking fund. Everyone is aware that when we are anticipating some expenditure in future, we may like to keep the money ready for that particular expenditure expected to occur at that time. For example, the housing societies would like to have a certain amount ready for the or would be repair of the building. For this purpose, the societies collect periodically a fixed contribution for each of their member to build. For this purpose, the societies collect periodically a fixed contribution for each of their members to build in the required funds. Such a collection is called as sinking fund. Thus, a sinking fund is an interest earning fund in which equal deposits are made at equal interval of time. These sinking funds need not be for building repairs only. They can be for machineries in a factory, vehicles in transportation company, and so on. Observe that a sinking fund is also an annuity in which the duration, periods, and the periodic payments are decided on the basis of the monetary requirements at the completion of the annuity. Hence, the example based on sinking fund will use the same formula for annuities. Before we start the examples, let us recall once again the following fact about annuities under study. All the annuities throughout this course are ordinary annuities. Therefore, the periodic payments are always made at the end of the period. And the second important thing is the period for the annuity is the same at which the interest is to be compounded. Let us write one example based on this now. Let us write first question. Find the amount for the ordinary annuity find the amount for the ordinary annuity with periodic payments with periodic payments as rupees 2000 at the rate of interest at the rate of interest 12% per annum for 2 years in each of the following case. If period of payment is yearly. So this is only one case we are taking here, and let us write the answer of this question. So here what is given to you, so R means installment is given to you and it is of rupees 2000. Rate of interest R is given and it is 12% per annum, and the investment is for rupees 2 years. So investment is for 2 years. So N is 2. So in case of for annual installment for annual installments, we know that the formula for the amount which we get or maturity amount R is given by A is given by R inside the bracket 1 plus R divided by 100 whole raised to the power n minus 1 and whole divided by R upon 100 R upon 100. So if I put all values, so R is 2000 inside the bracket 1 plus R is 12 divided by 100 whole raised to the power 2 minus 1 and whole divided by 12 divided by again 100 bracket complete. And if we solve all these things, you will observe that the bracketed quantity finally yields with 1000 divided by 12 into again 1.12 raised to the power 2 and minus 1. So if we do this calculation on your calculator, the total amount yields, it will be 2240 rupees. Okay, 40 rupees. The amount received on the closure of annuity is rupees. So therefore final conclusion we will write here the amount received the amount received on the closure CLOSURE, the amount received on the closure of the annuity is rupees is rupees 4,240 rupees, and therefore the capital invested is the capital invested is rupees r into n, and so it is equal to r into n means it is 2000 into 2 years means it is 4,000 rupees. That is the capital which we have invested. So now this is the end of this lecture, and remaining examples we will solve in the next lecture, and let's stop here. Thank you very much.